We either build the Terafab or we don't have the chips,
Musk declared during a presentation in Austin. That statement not only exposed the world's growing semiconductor shortage, but also unveiled the rationale behind a proposed 100 million square foot terafab, 10 times larger than Gigafactory Texas, designed to supply the AI chips needed for Musk's long-term vision, including up to 1 million AI satellites in orbit. As even industry leaders like TSMC and Samsung face mounting capacity constraints, Terafab could become the foundation of the largest technology empire in history. But with 1 million AI satellites in space, could Terafab really create the world's largest company? How do you build an AI empire capable of serving 1 million satellites in space? The answer is not simply by launching more rockets or designing more powerful chips. The real challenge is manufacturing enough advanced AI processors. That is why Terafab may become the most important industrial project Elon Musk has ever proposed, and why ASML's latest announcement provides one of the strongest signals yet that the semiconductor industry is already preparing for it. The first clue comes from ASML itself. During its Q2 2026 earnings call, Chief Financial Officer Roger Dassin confirmed that the company's capacity expansion plans for 2027 and 2028 already include demand from Tesla's planned Terafab semiconductor factory in Texas. ASML also announced it will increase production capacity for both EUV and DUV lithography systems by roughly 30% per year, from its 2026 baseline of approximately 65 EUV systems and 130 DUV systems annually. Even more importantly, ASML revealed that its 2027 EUV production is already almost fully booked, while a substantial portion of 2028 production has also been reserved. This means customers are committing billions of dollars years before the machines are even delivered, and Terafab is officially included in those long-term manufacturing plans. Why does this matter? Because ASML is the only company in the world capable of manufacturing EUV lithography machines used to produce the most advanced AI chips. Without ASML, there are no cutting-edge GPUs, no next-generation AI accelerators, and no large-scale autonomous computing platforms. Every major AI company, including NVIDIA, TSMC, Intel, and Samsung, ultimately depends on ASML's equipment. When ASML expands production specifically while acknowledging Terafab's future demand, it effectively validates that Tesla's chip ambitions are being treated as a serious industrial customer rather than a speculative concept. Now consider Musk's long-term vision. He has previously stated that Terafab could cover roughly 100 million square feet, making it approximately 10 times larger than Gigafactory Texas. Even more ambitious is the reported production target of 1 terawatt of AI computing hardware per year. To appreciate that scale, Musk has compared it with the United States' current electricity generation of roughly 0.5 terawatts, emphasizing that Terafab's output target would represent computing infrastructure on an unprecedented industrial scale. Whether that ultimate target is fully achieved remains uncertain, but even building a fraction of that capacity would make Terafab one of the largest semiconductor manufacturing complexes ever attempted. Now connect that manufacturing capability to SpaceX. Today, Starlink already operates thousands of satellites and plans to continue expanding its constellation. Looking further ahead, if SpaceX eventually deploys 1 million AI-enabled satellites over many years, a highly ambitious hypothetical scenario frequently discussed by Musk supporters, every satellite would require onboard AI processors for autonomous routing, beam management, collision avoidance, laser communications, cybersecurity, Earth observation, and edge inference. Unlike traditional satellites that mainly relay signals, AI satellites continuously process enormous volumes of data directly in orbit. That dramatically increases semiconductor demand. Suppose each next-generation AI satellite required only 2 advanced AI processors during manufacturing and several replacement chips throughout its operational lifetime. A constellation of 1 million satellites could therefore require millions of advanced AI chips, not including the massive ground infrastructure needed to train AI models, operate communication gateways, process user requests, and coordinate orbital traffic. Every satellite launched into orbit also increases demand for terrestrial AI data centers, creating a reinforcing cycle of chip consumption. This is where Terafab could fundamentally change Tesla's position. Instead of purchasing AI chips from external suppliers, Tesla could potentially manufacture much of its own computing hardware for Optimus robots, full self-driving vehicles, Dojo supercomputers, energy systems, and future space applications. Vertical integration on this scale would reduce dependence on third-party foundries while allowing Tesla to optimize hardware specifically for its AI ecosystem. The financial implications are extraordinary. Today, the world's largest technology companies, including Apple, Microsoft, and Nvidia, derive much of their value from controlling critical layers of computing infrastructure. If Terafab successfully supplies AI processors not only for Tesla's products but also for SpaceX's expanding satellite network and future AI platforms, Tesla would no longer compete only in automobiles. It would participate simultaneously in semiconductors, robotics, autonomous transportation, cloud AI, energy storage, and global satellite communications. That does not guarantee Tesla will become the world's largest company. Execution risks remain enormous, and many elements, including a 1 million satellite constellation and Terafab's ultimate production scale, remain long-term ambitions rather than completed achievements. However, ASML's latest confirmation changes the conversation. The world's most important chip equipment supplier has now acknowledged that Terafab is already influencing its production roadmap years in advance. When the only manufacturer capable of supplying advanced EUV lithography machines expands capacity partly because of your future factory, it suggests the industry believes the project is large enough to reshape global semiconductor demand. If Terafab reaches anything close to its intended scale while supplying the AI hardware behind autonomous vehicles, humanoid robots, Dojo supercomputers, and eventually an enormous AI satellite network, Tesla would not simply be selling cars anymore. It would be controlling one of the world's largest vertically integrated AI infrastructures, a position that could place it among the most valuable companies ever created. How could Terafab become the world's largest money-making machine? Traditional chipmakers generate revenue by manufacturing semiconductors and selling them to customers. Once a chip is shipped, the transaction is largely complete. Terafab, however, could operate under an entirely different philosophy. Instead of maximizing chip sales to outside companies, it could supply Tesla's own AI ecosystem, where every processor continues creating value long after it leaves the factory. In this model, the chip is not the final product. It is the foundation of multiple recurring revenue businesses. The clearest example is Robotaxi. A conventional car typically produces revenue only once at the moment of sale. A fully autonomous Robotaxi, by contrast, can generate income every day it transports passengers. Morgan Stanley has estimated that autonomous mobility could eventually become a multi-trillion-dollar global market. Every Robotaxi in Tesla's fleet will require increasingly powerful AI processors to interpret camera data, make driving decisions in real time, and continuously improve through software updates. That means every new vehicle placed into service creates long-term demand for more computing power rather than ending the revenue cycle. The same principle applies to Optimus. Elon Musk has repeatedly stated that humanoid robots could eventually outnumber humans and become Tesla's largest business. Even if Tesla deployed only a fraction of that vision, the economics would be extraordinary. Selling 10 million Optimus robots at an average price of $20,000 would represent approximately $200 billion in hardware revenue alone. But the robot itself is only the beginning. Businesses could subscribe to AI capability upgrades, fleet management software, predictive maintenance, specialized industrial applications, and enterprise support. Just as smartphones created an app economy, Optimus could create an entirely new software economy built on recurring subscriptions rather than one-time purchases. Terafab also strengthens Tesla's artificial intelligence infrastructure. Today, training advanced AI models requires enormous computing resources, and companies spend billions of dollars purchasing AI accelerators. Nvidia illustrates how valuable that market has become. In fiscal 2026, Nvidia reported $215.9 billion in annual revenue, demonstrating that AI computing has become one of the fastest-growing industries in the world. Instead of remaining a long-term customer of external chip suppliers, Tesla aims to manufacture much of its own AI hardware, allowing it to reduce dependence on outside vendors while optimizing chips specifically for full self-driving Optimus and future AI models. Another advantage is cost. Tesla has already announced plans to invest more than $20 billion in capital expenditures to expand AI infrastructure, robotaxi production, robotics, and semiconductor manufacturing. While that level of investment is enormous, owning more of the semiconductor supply chain could significantly reduce long-term computing costs as AI workloads continue to grow. Every improvement in chip efficiency lowers the cost of training AI models. accelerates software development, and improves the profitability of every AI-powered product Tesla sells. Perhaps the most powerful advantage is the feedback loop that Terafab creates. Vehicles generate driving data. Optimus robots collect real-world manipulation data. AI models learn from both. Better AI leads to better products, attracting more customers and generating even more data. As demand for intelligent machines increases, Tesla needs more AI processors, which Terafab can supply internally. That creates a self-reinforcing cycle in which every successful product increases demand for the factory's output, and every improvement in the factory strengthens the products. Unlike a traditional semiconductor manufacturer that depends on winning external customers, Terafab could generate demand from within Tesla's own ecosystem. Every new Robotaxi, every Optimus robot, every AI training cluster, and every software upgrade increases the value of the entire network. The chip itself may never be the biggest source of profit. Instead, it becomes the key that unlocks recurring revenue from autonomous transportation, robotics, AI services, and enterprise software. If this strategy succeeds, Terafab will not simply manufacture semiconductors. It will manufacture the computing foundation of an integrated AI ecosystem where every processor powers products and services that continue generating value year after year. That is why Terafab's ultimate business may not be selling chips, it may be transforming AI hardware into one of the world's largest recurring revenue engines. While much of Terafab remains under development, recent events suggest the project is steadily moving from vision to execution. In Texas, local authorities have already approved a tax reinvestment zone and incentives for the $55 billion first phase of the project, while school districts in Grimes County have also supported property tax abatements under the state's Jobs, Energy, Technology, and Innovation Program. At the same time, WIT Tech LLC, an affiliate linked to Musk's AI and space ventures, has secured more than 6,000 acres for the future campus and is renovating a 35,000 square foot engineering office in downtown Austin, indicating that research and early development activities are already underway. Although some local residents have raised concerns about infrastructure, environmental impacts, and rapid population growth, the pace of planning continues to accelerate. These developments suggest that Terafab is no longer just a bold concept discussed on stage, it is gradually becoming a real industrial project backed by land acquisitions, engineering facilities, government incentives, and long-term investment. The next question is no longer whether Terafab will be built, but whether it can be completed quickly enough to satisfy the explosive global demand for AI computing.